Assalamualaikum and hi. Today, my teammate and I will introduce you to the chapter 4, which is for sensor and transducer. But in our part, we got LVDT, inductive transducer. And it will be presented by Xian and me, myself, Muhammad Syamsani. What is transducer? Transducer is a device that converts one form of energy into another. Okay, take a note guys. All sensor contain transducer, but not all transducer act as a sensing devices. Okay, here I already provide you a picture that show you the difference between sensor and transducer in a real life. The transducer is on the left and the sensor is on the right. Okay, guys, what is LVDT? LVDT is stand for linear, V is for variable, D is for differential, and T is for transformer. So, LVDTs are incredibly accurate and reliable, also making them popular across industries for measuring linear distance, detecting vibration during stress test, or tracking actuator and brake pedal movement. And also, what can LVDT used for? LVDT are used across many different industries and have a very high degree of robustness. The advantages of LVDT sensor is used to detect vibration, mainly I think in the car engine, actuator, stress testing, and the brake pedal. But in this case, brake pedal are actually used for to measure how much you press on it. Okay, now is about structure of an LVDT. We have three main part, which is secondary coil 1, primary coil, and secondary coil 2. So, for the three coils, is a primary coil sit in the exact center, flanked by two identical secondary coils situated at equal distances from the primary. And we also have differential wiring, that the two secondary coils are wired in a series, but electrically 180 degrees out of phase with each other. So, the setup means the final output signal is the difference between voltages of these two windings. After that, we have the bar, which is ferromagnetic core. A cylindrical soft iron core is attached to a push rod. This rod connects to the physical object being measured and slide the core back and forth inside the hollow tube. So when we push the core back and forth, we can see the secondary output 1 and secondary output 2 will change. So this is show you how to get the idea how the LVDTs work. Okay, for the next part, I will pass it to my groupmate, which is Xian.
Okay, so how an LVDT works? So it is actually act like transformer also lah. It relies entirely on magnetic interactions to pinpoint position. So a continuous alternating current, which is AC, is applied to the primary center coil, which create a varying magnetic field. This primary excitation induces a current and voltage in the two secondary coils. So how does it induces current? So I will have a simple recap here lah. So actually it leads to the concept about Faraday's law of induction. So this law states that induced EMF is the electromotive force generated in a conductor due to a change in magnetic flux. So since they are moving of ferromagnetic core, which is this, the core, right? Okay, which act as a conductor. And there are secondary coils. Here are the secondary coils, these two. It will have changing of magnetic flux and and thus EMF is induced. So, okay, now we are talking about null position. So, initially, it stays in the null position. Null position is here. Okay, the iron core is perfectly dead centered inside the tube. So, when it is in the middle, an equal amount of magnetic flux is induced in both secondary coils because they are 180 degrees out of phase, so their voltages completely cancel each other out, resulting in a net output of 0. So to be simple, in the middle, there are no net voltage here. So the output voltage will be 0. Okay. So as a core slides away from the null position, the magnetic flux becomes unbalanced. For example, you see here go to the right side, right? Which is the upwards. So causes the voltage in the upper coil to exit the lower coil. It generates positive output voltage. Like just now, you guys can see the value here. You see? It is on the right and positive value, okay? And if go to the left, which is downwards, then vice versa. The output voltage will become negative. Alright, so it is the same, but just the direction problem. Okay, how can we use this as an engineer? So by monitoring these positive and negative voltage fluctuations, engineers can determine both the exact distance and also the direction an object has moved. So later I will talk about the example how to calculate all that, alright? Okay, so this will make up a graph which is amplitude of output voltage against displacement of the core. So this is the graph here, right? Okay, here's an additional info. I will talk about the graph first. So as you can see, the displacement more further
But
away from
before
the
that,
center, this is the center line. Okay, the displacement more further away, the voltage will be more higher, just like the theory just now, because the voltage difference is much more higher. So about negative displacement also lah. Since it is more far away, magnetic flux is more imbalanced, so it will produce more voltage difference. So this is the graph here. So here's an additional info. In ideal theoretical LVDT, the output voltage at the exact center would be 0 volt. However, in a physical component, the voltage never drops completely to 0 because of minor physical asymmetries in the coil windings and also harmonic distortion in the excitation source. So now I'll talk about advantages and disadvantages for LVDT. For minute variations in the magnetic core position, LVDT provide a high output. Besides, LVDT are highly repeatable due to their extremely low hysteresis. So what is hysteresis? Hysteresis is the phenomenon in which the value of a physical property lags behind changes in the effect causing it. As for instance, when magnetic induction lags behind the magnetizing force. Okay, besides, LVDT have sensing coils with low impedance. They can produce extremely low electrical noise levels. Noise level is very important for any instruments, especially in oscilloscope. So this is quite advantage for a circuit and to make sure the result is not affected. Besides, it is more or less power consuming as compared to other transducer. I think this is the most big disadvantages, which is very sensitive towards magnetic fields. Since LVDT is inductive transducers, it is sensitive to the stray magnetic field. Hence, an extra setup is required to protect from stray magnetic field. Usually, in industry, they will use the coil to like wrapping up the whole LVDT to prevent any magnetic field to interrupt the result to ensure more accurate reading lah. So it could be affected by vibrations and temperature also because LVDT is an electromagnetic device. So now I'll proceed to the examples. An SE LVDT is characterized by following parameters, input and output. You see the output got the negative and positive range and a range of negative to 0.5 to positive 0.5 inches. The question is, calculate the output voltage concerning core position for a core movement ranging from 0.45 inches to negative 0.3 inches. And the B, find the output voltage when the core is positioned at negative 0.25 inches from the center. We'll proceed to the A part first. For simple, the whole LVDT only got 1 inch, 0.5 for negative side, 0.5 for positive side. As result, 0.5 inch core displacement will result output voltage 3.2 volt, which is the maximum output voltage for positive side. 0.45 inch can be just simply calculate using the displacement over the max displacement times with the max output voltage. So you can get the output voltage for the 0.5 inch displacement. Same for the negative 0.3 inch, and you will get the value here. Actually, you can use these two values to plot the graph, which is a straight line also. And the negative actually just like showing the direction, so it is not a big issue. And same here for the part B, to find the output voltage, which is negative 0.25 inches from the center. Same, just take the maximum displacement, maximum output. This is for the negative side. And because the displacement is in negative direction, yeah, so you get the value negative 1.6 volt. That's all about the LVDT transducer. Me and my teammate hope that this video can help. Okay, that's all. Thank you.